All right, good morning, guys. This is Mr. Mascaro with you. We started talking about Chapter 2, Lesson 2 yesterday. So today what we're going to do is we're going to go through this lesson. Created a quick video for you guys about what is important here. All right, and hopefully over the next few days you'll be able to get a handle on what's happening with this lesson. All right, so Lesson 2, or again, Chapter 2, Lesson 2, right, and it'll help if you follow along in your book, right, is all about statements, conditionals, and biconditionals. All right, so yesterday we talked about a statement being a sentence that is either true or false. Okay, so a statement is just that, right? It's just a sentence, all right? And then we have to determine, or someone has to determine for us, the truth value of that statement, all right? So the truth value of a statement is either true or false, right? It's not maybe, it's not sometimes, it is either true or false. So we have to assign a value, right, of yes, this statement is true, or no, this statement is not true, all right, to that statement, all right. And then the negation of a statement, all right, is a statement that has the opposite meaning and the opposite truth value of that statement, all right. So for example, all right, let's say that I make a statement that I am 9 feet tall. Now, you have all seen me, all right? You know that I am not 9 feet tall. So that statement has a truth value of false, okay? The negation of that statement would be something like, I am not 9 feet tall, all right? And the truth value of that negation, all right, is true. All right, so a statement can be either true or false. And then a negation, it has the opposite meaning. It's a sentence that has the opposite meaning, all right, of the original statement. And that negation can have a truth value of either true or false. Okay, so let's take a look at an example of some statements. All right, and we'll worry about the compound statement and conjunction in a moment. All right, so right now, right, the figure on the right, looks like we have a triangle. All right, looks like two sides are equal. All right, looks like we have a 90-degree angle in there. All right, so this looks like an isosceles right triangle. All right, let's take a look and evaluate some statements associated with that triangle. All right, so oftentimes we will use letters like P, Q, R, etc. As kind of shorthand for our statements. All right, so the first statement, P, all right, the statement is the figure is a triangle. Now we take a look at the figure and we say, yes, the truth value for that statement is true. All right, so we take a look and we say that P, statement P, is true. All right, everybody okay so far? Good? All right. Next, statement Q. The figure has two congruent sides. All right, well, I see that we have these little, marks there, all right, which means congruence between sides. Okay, so I'm going to say that, yes, the truth value for statement Q is also true. All right, so we're going to mark Q as true. All right, and then finally, statement R. All right, so statement R says, all right, the statement is that the figure has three acute angles. Now, acute means less than 90 degrees. All right, well, I see one acute angle, I see two acute angles, but the third angle, right, is not acute. This is a 90-degree angle, which is not acute. So statement R is false. All right, so we can mark that. All right, so statement R is false. Okay, everybody good so far? All right, not nothing out of the realm here, right? Of holy cow, right? What's he talking about? Okay, all we know is that statement P is true, statement Q is true, statement R is true. All right. Now, the next thing that we want to do is we want to take a look at a concept called a conjunction. All right, a conjunction is two statements that are joined together with an and. Okay, so two statements, okay, joined with an and. All right, so we make one statement out of two statements. All right, and then the important part to remember about conjunctions is that a conjunction is evaluated as a single statement. Okay, so if I say that something is something and something else is something, all right, both of those pieces, right, both of those statements that we've joined together with the word and have to be true for the entire statement, for the entire conjunction to be true. All right, so let's take a look at some conjunctions with our triangle here. All right, we will write, statement P. Instead of rewriting the entire statement, the figure is a triangle, we can shorthand it just by using the letters representing the statements. All right, so we can write P and Q, and we read it as the figure is a triangle and the figure has two congruent sides. All right, well, by evaluating the individual statements, all right, we know that statement P is true and statement Q is also true. All right, now we can shorthand the word and. All right, this little symbol here, all right, means and. All right, just a little shorthand symbol. Instead of having to write out the word and, we just use a caret. Okay, so this means P and Q. Okay, statement P and Q. All right, so again, we can read that as the figure is a triangle and the figure has two congruent sides. All right, we determined that statement P is true. We determined that statement Q is true. So that means that the conjunction, the statement, the figure is a triangle and the figure has two congruent sides, that conjunction, that statement is also true. It has to be true. If both halves are true, all right, then the entire statement is true. All right, the important thing to remember here with a conjunction is that in a conjunction, both statements, all right, both halves have to be true in order for the entire conjunction to be true. Okay, so the last example was an example of a conjunction being true. Let's take a look at another conjunction. What if we were to make a conjunction out of statements Q and R? All right, so we have Q and R. Statement Q is that the figure has two congruent sides. Statement R is that the figure has three acute angles. All right, so we had previously determined that statement Q is true. However, statement R is false, okay, because the figure only has two acute angles. All right, so if we make a conjunction out of statements Q and R, right, it would read something along the lines of the figure has two congruent sides and the figure has three acute angles. Again, we can shorthand that, all right, by writing, Q, caret R, right, Q, little upside down arrow thing, R, okay. We had determined that statement Q is true, but statement R is false. So if I make the statement, right, the conjunction, that statement that says the figure has two congruent sides and the figure has three acute angles, all right, then that conjunction, that statement is false. All right, so in a conjunction, again, it's very important to understand that both halves of the conjunction have to be true in order for the entire conjunction to be true, right? So in a conjunction, both statements need to be true in order for the conjunction to be true. All right, and in this situation, because the figure does not have three acute angles, the conjunction Q and R is false. Okay, so what about conjunctions using negations? All right, so remember that we talked about the fact that a negation, all right, has the opposite meaning and opposite truth value of a statement. All right, so let's go back and take a look at a negation for statement R. All right, so a negation for statement R would say something like, right, the figure does not have three acute angles. All right, and we evaluate statement R, we negate statement R by saying not R. Okay, so not R, the negation of statement R, is the figure does not have three acute angles. All right, so since the figure does not have three acute angles, all right, then that statement is true. Okay, so down below, right, we take a look at this. All right, the little tilde before the R, all right, means not. All right, so that statement in shorthand, all right, not R, is true because the figure does not have three acute angles. Okay, so that statement is true. Good so far? All right, so let's take a look at a conjunction using not R. Okay. So we will say P and not R. Okay, which we can write as P, right, caret, and then tilde R, right? P and not R. The conjunction would be read as statement P, the figure is a triangle, and statement not R, right? The negation of statement R, the figure does not have three acute angles. So the entire conjunction would read, the figure is a triangle and the figure does not have three acute angles. All right, well, statement P is true, right? Because the statement is the figure is a triangle. Not R, the negation of R, is also true because the figure does not have three acute angles. All right, so the conjunction of P and the negation of R, right? The statement or the conjunction, the figure is a triangle and the figure does not have three acute angles. That conjunction, right, is true. All right. Again, we have to remember that in a conjunction, both statements need to be true in order for the entire conjunction to be true. Okay, now that we have conjunctions squared away, let's talk about something called a disjunction. All right, so where a conjunction is a compound statement, all right, that uses an and to separate the statements, all right, a disjunction is a compound statement that uses the word or. Okay, so what does that mean, right? In a disjunction, all right, if we use the word or, only one half of the statement, of the compound statement, needs to be true in order for the entire compound statement, right, for the entire disjunction to be true. All right, so let's take a look at examples of that. All right, so again, we have three statements. All right, statement P is that January is a fall month. Statement Q is that January only has 30 days. And statement R is that January 1st is the first day of a new year. Okay, so let's evaluate those individual statements by themselves. All right, so the first one, all right, is statement P. January is a fall month. Now we know that January is not in the fall, right? It's in the winter. All right, so that statement, all right, January is a fall month, has a truth value of false. Okay. Statement Q, January only has 30 days, right? Well, if you remember the little rhyme, right? 30 days of September, April, June, and November, all the rest of 31, except February, blah, blah, blah. Okay, you know that January does not only have 30 days, it actually has 31 days. So that statement is false. Okay. What about statement R? All right, statement R, January 1 is the first day of a new year. Okay, well, that is true. Okay, in our calendar, January 1st is the first day of the new year, so that statement evaluates out to true. All right, so let's take a look at some disjunctions that we can build uh, based on these statements. Okay, let's take a look at P or R. The disjunction January is a fall month or January 1st is the first day of a new year. All right, when we write a disjunction, all right, we use an upside down caret. All right, so it looks almost like a V. All right, so P or R, okay, also written as P upside down caret R, right? So the upside down caret is a symbol for R, for or, okay. And we evaluate the individual statements that make up the compound statement, all right, the disjunction. All right, so we know that P is false, but we also know that R is true. Okay, so we basically have a situation, all right, where one of our statements is false, but one of our statements is true. All right, so we can evaluate that as false or true. Statement P is false. Statement R is true. So we have a false or a true. In a disjunction, only one of the statements needs to be true, all right, in order for the disjunction to be evaluated as true. For the entire disjunction to be evaluated as true. So the compound statement, January is a fall month, or January 1st is the first day of the new year, that statement, that disjunction is true. Okay, because again, only one of the pieces has to be true in order for the entire statement to be true. The word or basically means, right, one or the other has to be true. They can both be true, all right, but one or the other has to be true for the entire statement to be true. All right, let's take a look at another one. What about if we create a disjunction based on P and Q, statement P and Q? All right, well, that disjunction would read January is a fall month, or January has only 30 days. So we take again the individual statements and we take a look at their truth values. All right, we know that statement P is false and statement Q is also false. All right, so we have a situation where P or Q evaluates out to false or false. If both parts of a disjunction are false, then the entire disjunction is false. All right, so the statement, all right, the compound statement, January is a fall month, or January only has 30 days, right, that disjunction is false. Okay, good so far. All right, so again, remember that in a disjunction, only one of the pieces has to be true for the entire thing to be true. All right, what about a disjunction with a negation? All right, so what if we were to write a negation for statement P? What might that look like? All right, so statement P says that January is a fall month. Well, the negation of January is a fall month would be, right, not P, right, not P. Okay, January is not a fall month. That's the negation of statement P. January is not a fall month. All right, so remember that a negation, all right, is a statement that basically says the opposite of the original statement, and the truth value is also opposite. All right, so January is not a fall month. All right, that evaluates out to true. All right, so not P. All right, so we'll write it down here. Right, not P. All right, is true. Okay, so let's take a look at that. All right, let's take a look at a negation using not P. All right, That erased it down here. Not P is true. All right, so our negation down here, not P or R. Okay, not P or R. We can read that as, right, the compound statement, January is not a fall month, or January 1st is the first day of the new year. All right, well, not P, right, the negation of P is true. Statement R is also true. All right, so we have true or true. So in other words, both halves of my disjunction are true, right, which makes the entire disjunction true, because again, in a disjunction, only one of the statements needs to be true in order for the disjunction to be evaluated as true. If they're both true, that's okay as well. All right, it's only when they're both false that we end up with a disjunction that evaluates out to false. Okay? All right. Okay, so the next kind of statements that we're going to talk about are called conditional statements. All right, so conditional statements are statements that we don't necessarily know the truth value of them right away. All right, and, right, depending on whether or not they are true or false, there might be a related statement associated with them. Okay, so a conditional statement is a statement that can be written in if-then form. The sentence given below is an example of a conditional statement. All right, so if the forecast calls for rain, then I will take an umbrella. Okay, my first statement, all right, my first statement, P, all right, the forecast calls for rain. Okay, that first part, all right, that almost question, if you will, all right, is called the hypothesis. All right, so the hypothesis is the part of a conditional statement that kind of sets the rule, all right, of whether or not we're going to do something. Okay, depending on the truth value, right? So we say, if the forecast calls for rain, all right, that's my hypothesis. All right, well, what's going to happen if that hypothesis is true? What happens if, right, the forecast calls for rain? All right, then the conclusion, all right, the second statement is, I will take an umbrella. All right, so we read that, we put those together as a conditional statement in the form, all right, of if something, then something. Okay, so, right, if the forecast calls for rain, then I will take an umbrella. All right, this little symbol here, all right, the right-handed arrow, all right, or the arrow pointing to the right, all right, is the symbol, all right, for an if-then statement. All right, so if I write P right arrow Q, all right, it reads as if P, then Q. Okay, sometimes they use the term, right, P implies Q. All right, I'm more of a computer coder. All right, so I like to read it as if P, then Q. All right, so in the example, all right, to the right, if the forecast calls for rain, then I will take an umbrella. All right, so again, we have a hypothesis, all right, represented here by P. We have a conclusion represented by Q. Okay, so that's a conditional statement. All right, so a conditional statement is it's a form of a compound statement, right? It's one statement is reliant on another statement. All right, on the truth value of another statement. Let's take a look at some more another example. Okay, and yep, here we go. All right, statement P. I eat a lot of pie. Okay, now whether or not that is true, we're not sure yet. I know the answer, but right now that's kind of thrown out there. Okay, what's next? All right, Q. I will gain weight. All right, so right, we can create a a conditional statement. All right, out of my hypothesis P, okay, if I eat a lot of pie, right, and my conclusion Q, I will gain weight. All right, so what might that look like? All right, well, this symbol here, right, is if P, then Q, all right, and we can write the conditional statement, all right, if I eat a lot of pie, then I will gain weight. All right, so that's a conditional statement, right? Um, right, one, if one, then the other, right? If I eat a lot of pie, then I will gain weight. All right, so that's an example. It's another example of a conditional statement. Okay, so now that we have a handle on conditional statements, right? If P then Q, all right, let's take a look at something known as related conditionals. Okay, so related conditionals are other statements that are based on a given conditional statement. All right, these are known as related conditionals, and they can take the form of converse, inverse, or contrapositive. Okay, the chart below kind of explains what each one is. All right. The thing that we have to remember, though, with related conditionals is that each statement, right, each set of converse, inverse, contrapositive statements, right, they have to be evaluated by themselves. All right. Just because something is true, right, if then, in the if then sense, okay, doesn't necessarily mean that the converse, inverse, or the contrapositive are going to be true as well, right? So we have to take each one of those new statements, new conditionals, all right, and evaluate them on their own merits. Okay, so let's take a look at an example of that. All right, so I have in the chart, right, I have two statements. I have statement P, which reads measure angle A is 35. All right, is 35. I have statement Q, all right, which reads angle A, right, is acute. Okay. So in my conditional statement, all right, I have if P then Q. Okay, and the example is if, right, the measure of angle A is 35. So in other words, if P is true, all right, my hypothesis, right, if my hypothesis P is true, then, right, my conclusion Q, all right, comes into play, is also true, right? So if the measure of angle A is 35, all right, then angle A is acute. And that is true, right? Because we know that acute angles, right, are angles that are less than 90 degrees and greater than 0 degrees. Okay, so that makes it acute, all right? So that makes angle A acute. So if the measure of angle A is 35, all right, then the then angle A is considered an acute angle. All right, makes perfect sense. All right. What about the converse of this statement, all right, of this conditional? All right, the converse is formed by exchanging the hypothesis and the conclusion of the conditional. All right, so we're reading this now, all right, as if Q then P. All right, so let's take a look at this, right? If angle A is an acute angle, then the measure of angle A is 35. Okay, well, that might be true, that might not be true, right? Just because an angle is acute, right, doesn't necessarily mean that an angle is going to have a degree measurement of 35. Okay, so we have to, again, take a look at these statements, all right, and evaluate them on their own, all right? But that is a converse statement, right? We basically switch the conclusion and the hypothesis, right? So now the hypothesis becomes if angle A is an acute angle, all right, and then the conclusion is the measure of angle A is 35. Okay, and then we have to evaluate that, as it goes. Okay. An inverse is formed by negating both the hypothesis and the conclusion, all right, in the conditional, all right? So remember, all right, that a negation, all right, is the opposite, if you will, all right, of a statement. Okay, so if it says if statement P, all right, is that measure of angle A is 35, then the negation of P, right, the negation of P, all right, is that the measure of angle A is not 35, right, and the negation of Q would be that angle A, right, is not acute. Okay, so, right, again, the inverse is formed by negating both the hypothesis and the conclusion. All right, so in this situation, right, we read, okay, this negation or this inverse, all right, as not P, then not Q. Okay, so if the measure of angle A is not 35, then angle A is not an acute. And again, an acute angle, right? Then again, we have to evaluate this as our, on its own merits. Okay, so just because an angle is not 35 doesn't necessarily mean, right, that an angle is not acute, right? So we have to be careful with those, all right, with the inverses. Okay, and then finally, a contrapositive, right? So a contrapositive is reversing, right, negating both the hypothesis and the conclusion of the converse of a conditional, all right? So where an inverse negates the hypothesis and the conclusion of the conditional, all right, a contrapositive negates the hypothesis and the conclusion, all right, of the converse. Okay, they were the converse of the conditional, all right, and that is read as, all right, not if not Q, then not P. Okay, so let's take a look at what that might read. All right, so if angle A is not acute, then the measure of angle A is not 35. All right, so now in this situation, right, the contrapositive seems to make the most sense. All right, where we have, right, if we say that the measure of angle A is, that angle A is not acute, all right, well, if it's not acute, it has to be either right or obtuse, okay, which means that the measure of angle A cannot be 35, okay, because if it was a measure of 35, right, it would make it acute. All right, so, right, this is something that we're going to look at more in class, all right, but how conditionals, all right, and converses and inverses work, and then conditionals, all right, their converse and their contrapositives work, all right. So generally speaking, right, if I have a conditional, all right, the converse may not necessarily be true, but the contrapositive, right, so if a conditional is true, all right, then the converse is not necessarily true, all right, however, the contrapositive will probably be true, right? So we have to but we have to evaluate those, right, on their own merits. Okay? Okay, so where does this all get us? All right, we talk about logically equivalent conditionals, all right? So a conditional and its contrapositive are either both true or both false, right? So they will evaluate out logically, right? They are logically equivalent. All right. Similarly, all right, the converse and inverse of a conditional are either both true or both false. All right. Statements with the same truth values are said to be logically equivalent. All right. So the takeaway here, all right, is that a conditional and its contrapositive are logically equivalent. In other words, if I have a conditional that uh, that evaluates out to true, then its contrapositive will also be true. Okay, if all right, the same is not true, however, of a conditional and a converse. Okay, if a conditional is true, the converse may or may not be true, right? We're going to need more evidence, all right, to support the converse. Okay, additionally, right, so in terms of logically equivalent, the converse and inverse of a condition are logically equivalent. All right, so again, if I have a conditional, all right, and I have a contrapositive, right, and they spelled contrapositive wrong, look at that. Right? I love picking up errors in the book. All right, so if they have a conditional, all right, and a contrapositive, all right, if the conditional is true, the contrapositive is true. The contrapositive is true, the conditional is true. If the conditional is false, the contrapositive is false, and so on. Okay? And then if we create converses and inverse of a conditional, all right, they are also logically equivalent. Okay? All right. Okay, so now that we have a handle on related conditionals, all right, and things that are logically equivalent, let's finish this out by talking about a biconditional statement. All right, so inverses, converses, and contrapositives are statements related to conditionals. Okay, if you make a compound statement from a conditional statement and its converse, all right, then you can write them as a single biconditional statement. All right, so a biconditional statement connects a conditional and its converse, all right, oftentimes by using the words if and only if. All right, a conditional statement and its converse must both be true for a biconditional to be true. So it's kind of like an and statement, all right? So it's kind of like an and compound statement. All right, so again, a conditional statement and its converse, right? That's important. A conditional statement and its converse must both be true for a biconditional to be true. All right, so let's say that we have two statements, all right? Again, right, when we have a statement, it's not necessarily that they're true or false. It's just a statement. We have to evaluate them in order to determine if they are true or false. All right, so statement P, angle O has a measure between 90 and 180 degrees. Okay, statement Q, angle O is an obtuse angle. All right, so we have our two statements, P and Q. All right, we want to make a biconditional statement, all right, out of those two statements. All right, so we would say, all right, angle O has a measure between 90 and 180 degrees if and only if angle O is an obtuse angle. Okay, so right, from a biconditional standpoint, all right, we we kind of join the two statements together. All right, so angle O has a measure between 90 and 180 degrees, obviously not inclusive, right? So greater than 90 degrees, right, less than 180 degrees, if and only if angle O is an obtuse angle. All right, so that's our biconditional statement. All right, so we would take a look at angle O. We would have to figure out the measure of angle O to determine whether or not it was, between 90 and 180 degrees. All right, and then we could go ahead and classify the biconditional statement as either true, right, or false. Okay, so again, just because something is a statement doesn't necessarily mean it's true or false. Okay, it is, we have to evaluate the truth values for those statements as we would for any statement. All right, so excuse me, in terms of chapter 2, lesson 2, that's it. I know we're, a lot of terminology, excuse me, a lot of kind of out of our normal course of mathematical thinking. All right, but from a logic perspective, from a moving forward perspective, right? Not just in mathematics and geometry, all right, but as we discussed in class the other day, right? These kinds of logical way of thinking, right, really holds a lot of weight in a lot of different fields. All right, you will see this kind of thinking in computer programming, right? You will see this kind of thinking in law. You will see this kind of thinking in terms of project planning, that sort of thing, right? So um, these concepts, these elemental concepts that we're talking about today, really go, aren't just a mathematical or a geometric way of thinking, right? They really do apply to a lot of areas in life. All right, so that's it for today. Thanks for watching the video. Be sure to kind of follow along in the book as you review the video. I'm going to post some problems for you guys to do on Blackboard. All right, and that's basically it. All right, this is Mr. Mascaro signing off. We'll talk to you guys soon. All right, bye bye.